All right, so picking up where we left off, hopefully my pen's working now. Number 6. So g of x is equal to -1. So again, this is going to be essentially -1 is for our y value or g of x value. So -1 equals -1/2 x plus 3. And we're solving for x. So we'll subtract 3 first to cancel it out. This will leave us -4 equal to -1/2 x. And then what we can do now is really multiply by -2 to cancel out the -1/2, because a negative times a negative will make a positive, and 2 times 1/2 will turn into 1. So multiply by -2 will cancel that out. So we'll have just 1x equal to -2 times -4, which is +8. And if you want to confirm if this is right, obviously you can plug it back in. So -1/2 times 8 plus 3, this should equal -1 at the end, right? So -1/2 of 8 is -4 plus 3. -4 plus 3 is -1. So yes, -8 is the right answer. So you can also take that, plug it in, and see if it comes out to what it's supposed to. So graphing the linear function, again, what's nice to do here, let me go ahead and make an x and y axis real quick. I don't necessarily know if where my x and y axis is going to need to go exactly, but I'll just put it here for now. We'll see where it ends up. All right. So for number 7, we'll plug in the same old numbers we did before. So I'll plug in -2, -1, 0, 1, and 2. And we'll see what y values we get out. So if I plug in -2, we have 3 times -2 minus 2. This would be -6 minus 2. Oops. Already getting ahead of myself. -6 minus 2 is -8. -2, -8. If we plug in -1, 3 times -1 is -3, minus 2 would be -5. If we plugged in 0, 3 times 0 is 0. 0 minus 2 is -2. If I plug in 1, 3 times 1 is 3. 3 minus 2 is 1. And if I plugged in 2, 3 times 2 is 6. 6 minus 2 is 4. So I don't have room for all these points, but I will graph the ones that I can. So -2, -8 would be way down here somewhere. Like I'd have to go -2 and then down 8. And I'm not going to have room for that. So I'll put that line back up there. So I can't really fit that point, but I'll try to fit the ones that I can. So I can fit 0, -2. 0, -2 is right here. I can fit 1, 1, should be right here. I can fit 2, 4 as well. And it doesn't have to be perfect, but again, you see, we could tell where the line's supposed to be. So we'll just connect these dots, make our line, and good to go. So we couldn't use all the points, but of course we were able to use some. And again, that's all we need is we just need some to make our line. So we'll do the same thing on number 8. I'll take the same numbers and plug them in. So -2, -1, 0, 1, and 2. So if I plug in -2, it'd be 4 minus -2, which is really 4 plus 2. So that'll come out to 6. If I plug in -1, I have 4 minus -1, which is basically 4 plus 1. So 4 plus 1 is 5. If I plug in 0, I have 4 minus 0, which is 4. If I plug in 1, I have 4 minus 1, which is 3. If I plug in 2, I have 4 minus 2, which is 2. So I can almost fit all these points in. I can fit -1, 5, 0, 4, 1, 3, and 2, 2. I can see where my line's going to go. So I'll draw it in. There it is. I've made my line. And then finally, we'll do it as well with this one. It's very blurry on the screen, but it's okay, I guess. So anyway, x, y, -2, -1, 0, 1, and 2. So if I plug in -2, we'll have negative 3/4 times negative 2 minus 1. So if I plug in negative 2, this will be positive 6/4 minus 1. So that's basically 3/2 minus 1, which is 1/2. So 0.5. Feel free to use a calculator if you want, I guess, with this, that would be okay. If you plug in negative 1, this would be 3/4 minus 1, which would be negative 1/4. If you plugged in 0, 0 is pretty easy because 3/4 times 0 is 0, and 0 minus 1 is negative 1. If you plugged in positive 1, this would be negative 3/4 minus 1, or negative 1 3/4. So negative 1.75. And if you plug in 2, this would be negative 6/4, which is negative 3/2. Minus 1 would be negative 2.5. So you're more than welcome to use a calculator to help you get those numbers. So I can fit these on here, negative 2.5. Oh, that would be positive. Negative 2 and positive 0.5. Negative 1 and negative 1/4. 0, negative 1. 1 and negative 1.75. And then 2 and negative 2.5. So it's a very low line, but there it is. That one's a little tougher because of the decimals, but it's really no different. You know, you get some numbers, you plug it in, you make your points, and you're good to go. There are other ways to do this. Some of you probably already know that, but we're gonna get to those next. So now, writing equations in slope-intercept form, using slopes and y-intercepts to write equations. So if I actually go back here, I want to show you something. In number 7, for example, this is in slope-intercept form. This has a slope of 3 and a y-intercept of negative 2. And we could have just taken that information and graph it. So negative 2 being the y-intercept, you can see on the y-axis that we have a point at negative 2. That's where this function hits the y-axis. It hits at negative 2. You can see that that's the point that they hit. And then it has a slope of 3, which, remember, slope is a rise over run. So if it's 3, it's rise 3 and run 1. And if you count here on this graph, you would count up 1, 2, 3, and run 1, and you get another point. You do the same thing for the next point. You rise 3, as you can see, and run 1. And it keeps that consistent slope. And that's true for all of these graphs. So it's also going to be true for this one. Or when we do get to graphing them, which we're not doing yet, but we're getting there. So write an equation in slope-intercept form. So you can see example 1a, the slope is negative 3 and the y-intercept is 1/2. So slope-intercept form, as you can see, is y equals mx plus b. Y equals mx plus b. M is the slope, b is the y-intercept. So if the slope is negative 3, then I'm going to put negative 3 in for m. If my y-intercept is 1/2, I'm going to put 1/2 in for b. And that's going to make my equation, negative 3x plus 1/2. And you can see that's what they have here as the solution. And for part b, it's the same thing, mx plus b. You can see the slope is 0, so I would put 0 for my slope for m, and my y-intercept is negative 2, so I'll put negative 2 as the b value. So I have 0x plus negative 2. Now 0x doesn't mean anything. 0x is no x's, so that's not going to be there. And then plus a negative 2 is really just minus 2. So overall, we'll just have y equals the minus 2. And that's why you can see that equation is y equals negative 2. So it's really just a matter of put the numbers in the right spot. Yes, we do more with this later, but that's sort of the beginning stages of it. So for our first example, slope of 7 and y-intercept of 2, y equals mx plus b. The slope being 7 means m is going to be 7, and the y-intercept being 2 means the b is going to be 2. So we have 7x plus 2. For number 2, again, y equals mx plus b. our slope is 1/3. So this will be 1/3 x. Oops, gotta get that 3 in there. And then my -1, my y-intercept, is my b value. So plus -1. Now, I will say, if you add a negative like this, you don't really need to write plus negative. We can just change this to a straight up -1. Instead of saying plus -1, you could just write -1. It means the same thing, just looks a little bit nicer. I'm going to move on to example 2. All right. So this one says write an equation of each line in slope-intercept form. So basically, you see the graph, and now we want to identify the slope and the y-intercept from the graph, and then put it in our equation. So if you look at graph A, we can see the y-intercept is at, look at the y-axis, -3, right? You can see on the y-axis, it crosses at -1, -2, -3. You can see that from the point as well, that it crosses at -3. So you can see the y-intercept here is at -3. But then the hard part, the slope. So what we're going to do to find the slope is the slope formula. You can see the slope formula here, which is y2 minus y1 over x2 minus x1. So in this problem, we're going to say that y1 and x1 and y1 are this point here, x1, y1. The x1 is 0, y1 is -3. And for x2, y2, we're going to be the next point. So point 2, x2 is 4, y2 is 3. So it's basically just the x and y of point 2 and the x and y of point 1. And if we follow the formula, y2 minus y1, that would be 3 minus -3. And again, you can see that here in their formula. And x2 minus x1 would be the 4 minus the 0. 4 minus 0. And so we simplify this, and it ends up being 6/4, or as you can see, 3/2. So I already pointed out the y-intercept was -3. And now from our formula, we know the slope is 3/2. So putting it all together, y equals mx plus b. My slope is 3/2, so that's my m. And then my y-intercept was -3, so that's my b. So plus -3, or just write it as -3. And you can see that's what they have in this example too. They do the same thing on this one. The y-intercept, as you can see, is at +2. And then the slope, you can see they use the slope formula. So this, what they have is x1, y1, and x2, y2. So y2 minus y1 would be -1 minus 2. And then x2 minus x1 would be 4 minus 0. So this ends up as -3 over 4, or -3/4. So that's your slope. And like I said, we've already pointed out our y-intercept is at 2. So knowing the slope and knowing the y-intercept, we can write our equation. Y equals mx plus b. We know our slope is -3/4, so that's the m. And we know the b was at +2, so +2. And again, you can see it filled in here as well. All right. I won't have time to do this whole thing today. We are going to break this up in a couple different days. So I will finish maybe this next page for today, and then we'll carry on with more stuff later on. But the next formula to worry about is called point slope form. So slope intercept form is y equals mx plus b. We just talked about that. That's called slope intercept form. But now we're going to talk about point slope form, which has a different formula. Point slope form is y minus y1 equals m parentheses x minus x1. So if this is slope intercept form, this is called point slope form. They're kind of the same, but they're different formats. Basically like different formulas of the same equation. So we've already talked about slope intercept. So we're going to move on from that. We're now going to move on to point slope form, which is this formula here. You can see it in the notes right here, the formula for point slope form. This first part kind of explains how they get point slope form, but mainly we're worried about the formula. So in the formula, the reason why it's called point slope is, as you can see, the m value is still the slope. But what's unique now is instead of having like the y-intercept, we have a point. Hence, it's called why it's called point slope form, because it tells us a point and it tells us the slope. So the point is going to be the x1 and the y1 values we see in the formula. So look at this example here. In this example, you can see that y plus 3, that 3 is your y1. I'll put the minus sign there because part of the equation. We'll talk about that. The m, and then x minus x1. So you can see this is the formula underlying the equation that they give us in example 1. Now in this example, we see this plus 3 as my y1, and we see this minus 2 as my x1. These values are going to make up my point. So the point on this graph is at positive 2, negative 3. Now let's talk about that. You can see it's down here on your paper. Let's talk about why it's positive 2, negative 3. And the main reasons have to do with the minus signs that are already in the formula. So keep in mind, this formula has the minus signs already integrated into it. So if it's still a minus sign, that means the number we put in was positive, because you subtract a positive number, you'll still see the minus sign. So if you still have the minus sign, it means the number that we plugged in was positive. So I still see the minus sign here. So this x1 value must be a positive 2. On the contrary, if the minus sign changed to a plus sign, it's because the number plugged in was negative. Because what happens if you subtract a negative number? Well, if you subtract a negative number, it turns into a plus, because subtracting a negative is adding. Subtracting a negative is like plus. So when I see this plus 3, I know that that must mean that we plugged in a negative 3, because that's how the sign changed from a minus to a plus. So that's why I have the y value as a negative 3. Of course, it should go without saying that the x1 value is your x, and the y1 value is your y. So it's 2, negative 3, not negative 3, 2. All right. So, and then of course, the slope here is negative 1/2. So it says identify the intercept. So what we're going to do is we're going to graph this. So what we'll start with is we'll start with the point 2, negative 3. And we'll put that point down there first. 2, negative 3 is this point here. So you put that one on there first. And then we carry on with the slope. The slope was a negative 1/2, which, as you can see, they've emphasized it as rise over run. Negative 1 being the rise, and the 2 being the run. So this would mean that you would go down 1 and right 2. And so they would kind of do it the other way around. It's the same thing, though. They would go right 2 and down 1, but the same as going down 1 and right 2. So you count that over, down 1, right 2, and it puts you at this point here. So you guys can see that in the bottom left of the screen. And so now you can just draw the line. You can keep that slope going. And you can see, I'll just fill in some points that they didn't do for you. And you can see that line. And so now with this line, you can see the intercepts. The y-intercept is at 2. And the x-intercept, if you carry on this way, is at negative 4. And so they mentioned that the y-intercept is at negative 2 and the x-intercept is at negative 4. So you're going to take the information and graph it and then see where the intercepts are on the graph. All right, that's going to be it for today. I think I'll carry on the rest of this in another video. Probably I'll make that tomorrow. But yeah, that's the start of 2.3. I'll see you guys in the rest of it later. Bye for now.